You cannot tell these two apart. One of them is a star. The other one is wearing a star's face, Vega. White, hard, about 25 light-years out. Vega's light carries a mark, a sharp drop across one narrow band of color. The hot hydrogen in its atmosphere burns it in. Call that a fingerprint. Webb found the same fingerprint 13 billion years back on something that cannot be a star, and the team that found it thinks something else. That the black hole at your galaxy's center may have started out just like it. Now, here is the part that broke them. This thing is as wide as our solar system. The models put its light near 100 billion suns. Nothing that burns does that. Not one star in your sky. Not 1,000 of them stacked on top of each other. So what is under the mask? Start with the rule you already know. When astronomers see something red in deep space, they blame dust. Dust swallows blue light and lets the red slip through. It is the same reason wildfire smoke can turn a whole city sunset orange. That rule is right almost every time. Here it fails. There is essentially no dust in this object. The red is coming from gas, hydrogen packed so tightly that it stops behaving like a cloud and starts behaving like a surface. That is your first look at the mask. Nobody was hunting for it. A team led by Rohan Naidu, then at MIT, was doing something more ordinary. They were hunting the earliest galaxies, the ones that looked too bright and too grown up for how young the universe was. They called the survey Mirage, or Miracle, because objects like that usually turn out to be one or the other. Then a dot in the data refused to behave. Very red, very bright, very small. Naidu later called it 1 in a billion. It was blazing in Webb's longest infrared filters, and at shorter wavelengths, it almost vanished. It took hours of staring with Webb's spectrograph to find out why. Split its light apart and you see something violent. Across one narrow step in color, the light does not fade. It falls off a cliff. On one side, bright. On the other side, almost nothing. Astronomers call that step a Balmer break. Vega has one. Every star with a thick hydrogen atmosphere has one. It is the fingerprint from the opening line. Now the number that matters. Take the best stars you can imagine. Tune every one of them to carve the deepest break physics allows. Current models put that ceiling near 3. This object measured 7.7. It is the deepest break anyone has ever recorded, and no crowd of stars can fake it. There is one more thing missing from the light. Metals. Iron, oxygen, carbon, the ingredients in your blood and your bones. In this object, there is almost nothing but hydrogen and helium, which means you are looking at gas that earlier stars had barely begun to touch. The universe was still clean. Try to feel how big the mask is. Light crosses our sun, front to back, in under 5 seconds. Light crossing this thing, if the models are right, needs about 14 hours. Same light, same speed. One takes a breath, the other takes most of a day. That is the job here. Take something impossible and stand a human being next to it. So we have a shell of hydrogen the size of a solar system. Something has to be lighting it. Fusion is out. Fusion is what runs your sun, and it is not a weak engine, but it cannot pour out 100 billion suns of light from a room that small. The fuel is not there. Only one thing in nature makes that kind of power in that little space: falling matter. Gas spirals inward toward a black hole. It crowds. It grinds against itself. It heats until it screams, and then it is gone. That energy slams into the inside of the hydrogen shell, and the shell is thick. Thick enough to stop light. Thick enough to stop X-rays, which normally pass through gas like it is not even there. so nothing escapes clean. Everything gets absorbed, cooled, and handed back out as soft red light, which is why, from that far away, a black hole can look like a star. Now put yourself at the edge of it. There is no ground to land on and no surface to touch. Just hydrogen getting thicker every mile you fall, glowing from the inside, hot as a stellar atmosphere, and as wide across as the outer solar system. And somewhere far below all of that, a hole in the floor of everything. And this is where it stops being one strange object. Since 2022, Webb has been finding little red dots scattered across the early universe. They show up in almost every deep image it takes. They are common back then, and in our era, they are gone. All of them. A whole population of objects filled the young universe. Then it left no version of itself behind for us to point a telescope at. Unless they did leave something, unless they grew up. Now hold on to something, because there is a 50-year-old problem waiting here. We already knew something that should not be possible. Black holes, billions of times the mass of the sun, existed before the universe turned 1 billion years old. There was not enough time to build them. A feeding black hole is a violent eater. The light it throws off pushes its own food away. Feeding chokes itself off. There is a speed limit on growth, unless you bury it. Current models suggest one way out. Pack the gas around a black hole tightly enough, and the light never gets out to push. It is trapped inside the shell, absorbed and recycled. The brakes fail. The thing eats without a limit. So the mask is not a disguise. The mask is a feeding tube, and that lands directly over your head. There is a black hole at the center of your galaxy, around 4 million times the mass of the sun. You are circling it right now at roughly 500,000 miles an hour. One lap takes more than 200 million years. The researchers argue this way of growing must be common. Common enough that every massive black hole, including ours, may have worn the mask. You just watched a star turn out to be a mask, and the next one is closer to home. Subscribe so it finds you, because nobody has taken this mask off. Everything here is a model, a very good one. It explains the color, the cliff, the brightness, and the missing dust in a single move. But another group ran different numbers and got a different monster. A single star made almost entirely of hydrogen and helium, around 1 million times the mass of the sun. No black hole inside it at all. That should be impossible too. Both answers rewrite something. And until Webb goes back for a deeper look, this thing keeps its face. Think about the trip that light made. It left when the universe was about 660 million years old. No Earth, no sun, no oceans, no oxygen, nobody to see it. It crossed 13 billion years of empty space. Then it ended inside a cold mirror, 1 million miles above your head. And a small, warm animal caught it. That is you. 80 summers, 1 blue rock, 1 short life spent looking up. And in that life, you stared at a face 13 billion years gone, and worked out what was hiding behind it.